All right, you've already learned about direct variation. Do you guys remember what the formula was for direct variation?
Y equals
Y equals kx. Yes, this is direct. So you're learning inverse variation. You'll see that the formula is just rearranged a little bit. Okay, so this is the major thing you need to recognize. Now look what happens when they graphed it. See how different the graph is? Where a direct variation is a straight line, inverse variation is a funny little L.
Does it still have to go through the zero, the origin?
No, this one's all over the place. In fact, it cannot equal 0. Well, the point could, but the slope can't be 0. So the slope can't be a 0 ever. So you can't have y equals k over 0. Okay? All right, so let's practice one of these. This is example 1. Put this in your journals. We have 5y equals x. You're going to solve for y every single time and tell me whether it's direct variation, inverse variation, or neither one. Okay? Because it could be neither. All right. So in this one, how do I solve for y?
You divide.
Very good. We divide that 5 away because it is multiply. So we get y equals... Now there's a 1 here, so I can say 1/5 x. Okay, I mean you could do the division, it'll be some decimal, but you don't want to do that, just leave it. Okay, what is this? Direct, inverse, or neither?
It's direct.
Very good. This is direct variation.
And how is that direct?
Because it's a number in front of x. Y equals kx.
Oh, it can be a fraction too?
It can be a fraction as long as it's a number in front of x. Yeah, it can be a fraction. Okay, for b, we have 1/3 y equals 1 over x. Woo, this is ugly. All right, so solve for y. How do I move that 1/3?
Divide.
Divide by 1/3. When it's a fraction, you flip it and multiply. So times 3. So we get y equals 3 times 1 is 3 over x.
Is it just 3?
Yeah, 3 over 1. 3 times 1 is 3.
This is inverse variation.
This would be inverse variation.
Because it's something over.
Yep, because it's a number over x.
Want me to help you?
So inverse variation is always going to be a fraction?
It's going to look like a fraction, but it's not going to look like a fraction in front of the number. It's going to be a fraction.
Okay.
If it's on top or?
It's got to be on top. If it's on the bottom, you can write it like this first one. Okay, let's do, we have negative x equals y plus 7. Okay, already you should be able to recognize this one. But let's get the y by itself. So move that 7. I'm going to subtract 7. So I get negative x minus 7 equals y, which is the same thing as y equals negative 7 minus x. Which one is this?
This is direct. Or it's neither.
It's neither. Because why? Why?
Because it's not direct, or they don't have the x in front, and they don't have it as a fraction.
Well, they do have an x in front. It's a negative 1.
Oh, but
So tell me why this is not a...
Because it's not the right formula?
it's not.
Why? It's a real easy
It's
answer.
not in the right way.
Why? What's wrong?
It's not wildly
It's
correct.
negative.
Because the y is on that side.
The y's fine. It's right here, guys.
The minus?
You can't have a plus or minus anything on the end of it.
Oh, it only has to be the zero.
That's the reason. If I had just had y equals negative x, that would be direct. If I had y equals negative 1 over x, that would be inverse. But because you have a plus or minus number at the end of it, it's neither. Okay? Just make sure you know that. Okay, number 1 on your paper. Y minus 1 equals 2x. We are solving and then answering whether it's direct, inverse, or neither. Okay, you should be able to look at this right now and tell me that it's going to be neither.
It's going to be neither.
because you have that -1 that we're going to move. We're still going to do it because it says to do it, but I can look at this and go, well, this is going to be neither. Because I'm going to say +1. So I get y equals 2x plus 1. So because of that +1 on the end of it, this is neither. Okay? So the neithers should be fairly easy for you to point out. All right? All right, how do I get y by itself on number 2?
Multiply 1 and 5.
Well, it is multiply, so we would divide, but since it's a fraction, we flip it.
So 5 times
5 over 1. Okay, so then y equals 5x, because 5 over 1 is just 5.
So that's direct variation.
So this would be direct variation. Make sense? Any questions on number 2? All right, let's do number 3. 2y equals 1 over x. So how we get rid of that 2? Divide by 2.
Cancel.
So over here we're dividing by 2.
Point.
So this is
We usually divide it by 1.
well, you're dividing by 2 over 1, or multiplying times 1 over 2, right?
Yeah.
This one looks weird though. One over x divided by 2 over 1, which would be times 1 over 2. So that'd be 1 over 2x. So that's the same thing as saying y equals 0.5 over x.
So it's inverse variation.
Mm-hmm. That's a harder one. All right, so let's look at example 2. All right, so this graph on the right shows inverse variation, right? Which equation relates x and y? So we need to figure out which of these equations shows the inverse variation. So what's the inverse variation formula?
Oh, k equals
Y equals
kx.
k over x. Okay, so we know that this is the formula. Well, looking at this graph, what information can we pull off of this graph? The point, right? Yeah. So can we plug in the point to find what k is?
Yeah.
Sure. So 2 is x, so I'm going to put that on the bottom. And then y is 1. Now, how do I solve for k? Remember, because this point is x comma y. So you plug in the y on the outside and the 2 on the bottom.
Okay.
So how do I get the k by itself? This is division. What's the opposite of division?
The y.
This is y, so the 1 is y.
Oh.
So yes, Eliana had it right. Multiply times 2. So multiply times 2. So that leaves me with just k. What's 2 times 1?
2.
So now I can rewrite my equation with y equals, what's k equal?
2.
2 over x. So this is my new equation. So A, B, C, or D, which one is the correct answer?
B.
B would be the correct answer. Okay, so if they give you the point on this line, on this slope, then I can solve for k. You just plug in x and y. Guys, if you don't understand how to write a point, this x comma y, this is very important for the future. You have to remember, when you see a point written like this, x is the first number, y is the second number. It includes negatives if it has a negative. Okay? Let's look at, example 3. All right, example 3, the graph shows the number of hours y it takes x number of workers to paint a room. For A, they're asking, how does y change as x increases? So looking at y, what happens as you get more workers? What happens to y?
It goes up.
No, the y goes which way?
Oh, to the left.
The y goes down. So the more workers I get, the less time it takes to paint, right?
X increase.
So write that down. As x increases, what happens to y?
Goes down.
Y decreases. Which makes sense, right?
Yeah.
When you get a lot of people working on something, it makes it faster. Okay, for B, does x and y show direct or inverse variation? Is this direct? Yeah, this is inverse, right? Inverse variation.
It shows, yeah.
Yeah, because you can see the formula right here. So we're going to use this equation to solve for when x equals 5, how many hours would it take? So we have the equation. We have y equals 8 over x. They told me that x equals 5. So that means I have 5 workers. So I'm going to plug that in to solve for how long it takes me to paint. So where do I plug in that 5?
The bottom.
So I say 8 over 5, which divide that, what would you get?
8 divided by 5.
Yep, it'll be a decimal.
1.6.
So it's going to take 1.6 what? Seconds, hours, minutes? 1.6 hours for those 5 workers to paint the room. Very good. Any questions? All right, let's do number 4. On your paper. Suppose y varies inversely with x. Okay, so what's the inverse equation?
Well, y equals 8 over y equals 2 over
K over x. So this is saying y is inverse with x. And they tell you, and y equals 3 when x equals 1. So this is everything they told us. Write an equation that relates x and y. So what information do I have?
y equals 3.
And x equals 1. So I can plug those in to solve for k, right? Because the k is what you want to have a number at for your equation. So I'm going to plug this in. I have 3 equals k over 1, right?
Yes.
How do I get the k by itself?
Multiply.
Multiply times 1. So what does k equal? 3. So my new equation would y equal 3 over x. So here is your inverse variation equation. This is what you're going to be doing on the lesson.
So they wanted us to solve for k.
Yeah, whenever they ask you to write an equation showing whether something is inverse variation or direct variation, they want the y and the x not solved. They want the k solved. But a lot of times they're going to give you the y and the x, so you solve for the k. Or sometimes they'll give you k and the y, and you got to solve for x. You just rearrange till you get it. Okay, last one, number 5. In example 3, where we talked about the workers painting, how many hours does it take 3 workers to paint the room? So we had this equation, y equals 8 over x, right? What did x stand for?
5
No, what did it stand for? What is 5? 5 is what?
hours, workers.
The number of workers. So in this case, we have 3 workers. So where am I going to put the 3?
In the place of X.
Where the place of x is. Very good. So I'm going to say y equals 8 over 3 instead of 8 over 5. You're going to divide that and tell me how many hours it takes 3 workers. You can have it as a fraction or a decimal. That sounds right.
No, 2.7.
Bless you.
Thank you. My book says 2 2/3, so 2.6, 2.7, they're both right there.
Because I'm just rounding it.
I would probably accept either answer. So 3 workers is going to take a little bit longer. All right, any questions? Okay, I do want to practice this a little bit, but I know we ran out of time. So I want you to do numbers 4 through 15. That's it. I will shorten your assignment.
Yes. Thank you.
And you've done on your own numbers 1 through 5. Make sure you turn that in.